Okay, for 6b, this is one where we have to draw a picture this time. So I'm going to go ahead and read this, and I'm going to draw a picture as we go through this. It says, from an airplane at an altitude, which is a height of 1,200 meters, the angle of depression to a rock on the ground measures 28. Okay, so we have an airplane that is flying at an altitude of 1,200 meters, so I'll put 1,200 there. And we have an angle of depression. So angle of depression means that looking down at something. So I have a picture that looks something like this. An angle of depression would be measured there. It's not measured inside here because angles of elevation and depression have to be measured from the horizontal like I have there. So this 28 degrees that it says here has to be this angle here on the outside of the triangle. So this is 28, to make that a little bit more clear. That would be 28 degrees right there. And the rock would be considered down there. Now what it's asking for is it says find the distance from the plane to the rock. So it's not going to be this distance because that distance is just the ground distance. You want the actual distance from the rock to the plane, so it has to be this diagonal part right there, and that's what you're going to use. Okay, so when I do this problem, there's a couple different ways that I can approach this. I could take 90 degrees and so take 90 minus 28 to get the angle that's inside the triangle right here. Or I can use a rule from geometry. There's a rule from the geometry that says that if you've got two parallel lines and a line that goes in between, we have something that's called alternate interior angles. This angle and that angle would be equal. So because this dotted line is parallel to the ground right here, that means that this angle inside the triangle would also end up being 28 degrees. So this and this are both going to be the same. The most important thing is you have to get an angle that ends up inside the triangle. Whether you subtract from 90 and get the angle inside here, or whether you get that one, you have to have an angle inside the triangle in order to set this up correctly. So now what I want to do is I want to pick a trig function that relates a side that I'm given to a side that I'm trying to find. I'm trying to find the x here, so that would be hypotenuse because that's opposite the right angle. And because I'm working with this angle here, 28 degrees, the 1200 would represent the opposite side. So I want to find a trig function that relates the opposite and hypotenuse. So that's going to be sine. Okay, so sine 28 degrees I'm going to use. That's going to equal opposite over hypotenuse. So opposite is 1200. And I have that over x, and so now I want to solve for x. So what I have to do is I'm going to multiply both sides by x to get rid of the fraction, and I get x sine 28 degrees. That equals 1200. And then I need to solve for x, so I got to divide both sides by sine 28 degrees. So I'm going to do that right here. And so now I just need to do 1200 divided by sine 28 degrees. I'm going to put this in my calculator. I want to make sure your calculator is in degree mode. And so when you put that into the calculator, you should get 2556.07. And that would be in terms of meters. Okay, so that would be your answer. So that would be the total distance on this diagonal. 1,200 meters. It's okay to leave your answer in terms of meters because it doesn't say to write it in any other kind of unit.